Hello, my name is Lamar Hamid, and I'm a third-year civil engineering student at the Schulich School of Engineering doing a minor in entrepreneurship and enterprise development. In this video, I'll be presenting my summer research project, Mapping Digital Pedagogies in Futuristic Engineering Education, a scoping review of soft and entrepreneurial skills development, made possible through the NSERC Undergraduate Student Research Award. I want to begin by acknowledging the land on which we stand. The University of Calgary, located in the heart of southern Alberta, both acknowledges and pays tribute to the traditional territories of the peoples of Treaty 7, which include the Blackfoot Confederacy, comprised of the Siksika, the Piikani, and the Kainai First Nations, the Tsuut'ina First Nation, and the Stoney Nakoda, including Chiniki, Bearspaw, and Goodstoney First Nations. The city of Calgary is also home to the Métis Nation of Alberta, Districts 5 and 6. Engineering education is built around technical mastery, from solving equations and analyzing data to designing the systems that make everyday life possible. But in focusing so much on technical skills, we often overlook the human side of the profession, soft skills, which are interpersonal traits for effective communication. Yet many of us graduate without learning how to pitch an idea, lead a team, or collaborate effectively. In 2025, engineering education has access to a vast range of digital tools, from virtual reality and artificial intelligence to simulations and game-based learning platforms. These technologies have gained attention for their ability to enhance technical understanding, visualization, and design accuracy by creating immersive learning experiences that mirror real engineering practice. While these tools clearly enhance technical learning, the question remains, can they also support the development of human skills like communication, teamwork, and innovation? These soft and entrepreneurial skills are increasingly important in modern practice. However, their connection to digital learning tools in the context of engineering education remains underexplored. Through my research, I aim to map how digital tools are currently being used and identify where opportunities exist to broaden their impact. The goal is to show how these approaches can extend learning beyond technical training, preparing engineers for adaptive, innovative, and collaborative professional environments. Now, to quantify this goal, I asked three key questions. What soft and entrepreneurial skills are most targeted in engineering? What digital tools help develop these skills? And how can we integrate these tools into engineering programs? To answer these questions, I conducted a structured search across Scopus, IEEE Explore, and Google Scholar for peer-reviewed studies examining the interplay between digital tools, educational methods, soft skills, and entrepreneurial thinking. The search returned 424 results. Studies were then screened against inclusion and exclusion criteria. Only those published after 2010 to focus on recent technological advancements and examining digital learning, soft skills, or entrepreneurial thinking in engineering or higher education were included. 39 studies were included. Each study was coded and categorized across three dimensions: the digital tools used, the teaching methods applied, and the skills they aimed to or reportedly developed, and findings were reported. 5 key skills were identified as the most frequently discussed across the broader body of literature: communication, teamwork, leadership, critical thinking, and innovation. While studies varied in focus and methodology, these skills consistently emerged as indicators of professional readiness, particularly in research focused on aligning engineering education with modern industry needs. The review identified several digital tools originally used for technical training, but clear links emerged between them and the development of the key skills. Among the most discussed was BIM, a 3D design tool used in construction that enables multidisciplinary collaboration and was linked to stronger communication, teamwork, and leadership. VR tools showed similar results, offering interactive environments where students can visualize projects and collaborate in shared digital spaces. AI tools were associated with critical thinking by guiding students through decision-making processes that require evaluation and reasoning. Simulations and gamified learning platforms were connected to innovation and teamwork for engaging students in interactive problem-solving and experimentation. The impact of these tools depends on how they're embedded into teaching. 3 main approaches emerged: formal coursework integrating technology directly into structured lessons and assignments, project-based and challenge-based learning engaging students in real engineering or societal problems that require design, collaboration, and problem-solving, and extracurricular activities extending learning beyond the classroom through hands-on team-based experiences like student competitions. Looking ahead, my research aligns with the University of Calgary's Ahead of Tomorrow strategic plan, which promotes interdisciplinary education and innovation. By showing how digital tools can foster entrepreneurial thinking in engineering, this work supports the university's goals of preparing students to lead and adapt in a rapidly changing world. I'm also happy to share that my findings are on track to be shared through publication in the ASCE Journal of Civil Engineering Education and have been submitted for presentation at the Canadian Engineering Education Association and IEEE Global Engineering Education conferences. As I conclude, I'd like to thank my family for their constant support and the SU and judges for their time and for providing this opportunity to share my work.